In this video, we are going to take a look at surds, and specifically proofs using surds. Now this is found in grade 11 maths, however it is also used in your grade 12 final paper. And a quick answer to some of your questions: what on earth is a surd? It's equations or algebraic expressions using a root, an nth root. Alright, so let's jump right in. The typical questions you get with this would say to you, without the use of a calculator, show that. Now, the word show that means prove. That would be a similar word for that instance. Alright, prove that. And they give us the following sum. They say 3 over root 3 plus 2 plus 6 over root 3 equals 6 minus root 3. In other words, what they want you to do is show that this left-hand side over here is equals to this right-hand side. Now, the fantastic thing about algebra, as I've said before, is we can use steps. We have step 1 and step 2. Now, these proofs only require 2 steps. However, they are slightly intricate. Now, step 1 is pretty cool. It is not BODMAS. Step 1 this time is to rationalize the denominator. Rationalize denominator. And how do we do that? Well, we need to multiply denominator, my apologies. We need to multiply with the conjugate pair. So how do you rationalize the denominator? Multiply with its conjugate. And what on earth is that? Well, let me show you before we even look at step 2. So what we're going to do here is we're going to work with the left-hand side. Okay? What is the left-hand side? It is 3 over root 3 plus 2 plus 6 over root 3. Okay, now multiplying with its conjugate. We need to isolate these. So we need to look at each fraction separately. And we need to ask ourselves, do we have a root or do we have a surd in the denominator? Here on the left hand side, yes we do. And that is a problem. We do not want surds. Let's elaborate there. No surds in denominator. Okay, that's very, very, very important that we get that in our minds. We do not want a surd in the denominator, so we need to multiply its conjugate pair. So what that looks like is we have 3 over root 3 plus 2, and here's where we need to multiply the conjugate. Alright, and what is the conjugate here? Well, firstly I need to tell you, when you multiply something, we technically need to multiply with 1 because we do not want to change anything. Alright, we want to simplify it, but we don't want to change the value of it. So the conjugate of root 3 plus 2 is root 3 minus 2. And for this to be 1, we just make it a fraction divided by itself. Alright, and we can't forget the other fraction over here. We have 6 over root 3. Now, root 3 over here in the denominator is a problem. Because why? No surds in denominator. Let me actually put this in a cloud quickly. We do not want surds in our denominator ever. That's how you know when to multiply it with a conjugate pair. So if we had to say plus 6 over root 3, we now need to multiply its conjugate pair, but there's no pluses or minus there, so we just multiply root 3 over root 3. Okay. Now, the cool thing here is by simply applying the rules of fractions, we can simplify this duty. So let's do top, top, bottom, bottom. Top times top here is 3 times root 3 minus 2 over, we're going to get root 3 plus 2 and root 3 minus 2. Alright, and on this side plus 6 times root 3 just becomes 6 root 3 over, now root 3 over root 3. Let's take a look at this quickly. Root 3 times root 3 is technically 3 to the power of a half times 3 to the power of a half. Remember in our previous video we discussed that a root is actually the power of a fraction. And because that's a multiply and the bases are identical, because 3 and 3 are the same thing, we now just add the exponents. So that becomes 3 to the power of a half plus a half. What is a half plus a half? It is 3 to the power of 1. So root 3 times root 3 is simply 3. Alright, fantastic. Okay, let's carry on. So, now, I just told you that root 3 times root 3 is 3, right? Now let's take a look. If we had to FOIL these bottom two brackets, root 3 times root 3 is 3. Root 3 times minus 2 is minus 2 root 3. Let's write that down quickly. And then we're also going to FOIL at the top here. And I just want to change color quickly. Alright, we're going to times that out on top as well. So we have 3 root 3 minus 6 over. And now we need to FOIL the bottom brackets. Root 3 times root 3 is 3. Minus 2 root 3 plus 2 root 3 minus 4. And let's not forget this other fraction, plus 6 root 3 over 3. Alright, let's go back to the original color. And what we're going to do now is we're going to apply step 2. We've multiplied them out. And step 2 is simplify. It's as easy as that. So step 1 was rationalize the denominator by multiplying the conjugate. And step 2 is simplify. So simplifying this, we get in the numerator there 3 root 3 minus 6 over. Now if you look here, we have minus 2 root 3 plus 2 root 3. In other words, they cancel each other out. What are we left with? 3 minus 4 plus. Now cool thing here, when dealing with something like 6 root 3 over 3, I want you to imagine the root 3 becoming an x. 6x over 3. How would you simplify that? Well, you would say you would divide the coefficients. You'd say 6 divided by 3 equals 2x. I want you to do the same thing here. 6 divided by 3 there is 2 root 3. Alright, so our rules of surds when it comes to multiply divide is similar to that of using general algebra with variables, except the multiply does get a little different. I just want you to remember when handling multiplication, if we had root 3 times root 2, that would actually become root 3 times 2, which becomes root 6. But we're not dealing with that right now. What we're dealing with is a divide, and we could actually just imagine that root 3 was x. So 2 root 3. Now we're not done. Remember our goal in the beginning. We had to show that it's 6 minus root 3. So let's simplify further. We can see 3 minus 4 can be taken further. That becomes minus 1. Which means this thing would become minus 3 root 3 plus 6 plus 2 root 3. How did I get that? Well, we used the numerator over here, 3 root 3 minus 6, and we divided it by minus 1. 3 root 3 divided by minus 1 is minus 3 root 3. Plus 6 divided by minus 1 is plus 6. And then this we just conveyed over here. Alright, now we are not done. We do not have our objective. But if we simplify this, let's look here. We've got minus 3 root 3 plus 2 root 3. What's minus 3 plus 2? It's minus 1. So 6 minus 1 root 3. I actually just want to remove that 1. It looks a little worse for wear. There we go. That looks much better. And what does that look like? Well, that looks like our question, does it not? Alright, let's do another one quickly. Without using a calculator, show that root 2 over 1 plus root 2 plus 4 over root 2 equals 2 plus root 2. Now again, we need to use the one with more juice. You guys have got it by now, huh? Okay, so let's race through this as fast as we can. We've got root 2 over 1 plus root 2. And what are we going to do? We are going to multiply that with its conjugate. We know we just replaced the sign, so we're going to multiply with sorry, I was looking at the numerator there. We are going to multiply with 1 minus root 2 over 1 minus root 2. Cool. And then we need to look at the other fraction there, plus 4 over root 2, multiplied root 2 over root 2, multiplied root 2 over root 2. And I know some of you are like, why did he not write left hand side this time? It's because I was in such a rush, ladies and gentlemen. You were 100% right. We need to write left hand side equals, and then we carry it on there. Alright, so equals. Let's multiply these guys out. We've got root 2 brackets 1 minus root 2 over. We have 1 plus root 2 multiplied 1 minus root 2. Cool. Plus 4 root 2 over 2. Just going to carry on next to it here for the sake of space. Equals. Alright, let's FOIL that in. We get root 2 minus 2 over. 1. Okay, so then we're gonna get, just gonna show you my thinking here. We have 1 times 1 gives us 1. Then we have minus root 2 plus root 2. They're gonna cancel each other out, and then we're gonna have minus 2. So 1 minus 2. Okay, cool. Plus, and 4 over 2 root 2. 2 goes into itself once, into 4 twice, plus 2 root 2. Let's simplify further. Root 2 minus 2 over minus 1 plus 2 root 2. Alright, now root 2 divided by minus 1 is minus root 2. Minus 2 over minus 1 plus 2 root 2 equals. Alright, again, similar to the one before. We have minus root 2 plus 2 root 2 becomes plus root 2. So our final answer over here is going to be 2 plus root 2. And that's equals to our right hand side. Right, ladies and gentlemen, thank you so much for watching. Please like, subscribe, and share, and become part of the Whiteboard SA family. Cheerio!